Hello and welcome. It is an exciting day for Excel users today because regular expressions have come to Excel. Hooray! With various caveats. One is they were already there. You can do regular expressions through VBA, through Python for Excel, through Power Query if you call R or other languages, etc. There's lots of weird ways to do it, but now you can do it in the grid, which is a little bit closer to hand for most people. Second caveat is it's still in beta. If you have Office 365, then you can go into your account settings and switch it to Microsoft 365 Insider. That'll put you on the beta channel. Not everybody on the beta channel gets every release right away. So I remember I and many others were sitting around for weeks begging for Python because that one rolled out pretty slowly. Maybe this one will roll out faster. I don't know. But I got it as part of the first release, so I'm going to make a quick video about it. So very simply, if you don't know about regular expressions, the simple idea is a regular expression is a pattern. And there are three new functions in Excel for regex. So you can test to find if a text matches a pattern, and then you can extract a substring from a text based on a pattern, or you can replace a substring and shuffle things around. This topic goes deep, and I think the risk of a shallow coverage is I've already seen some people commenting on the announcement saying things like, but you could just use left and right and mid and whatever to do the same thing with existing Excel functions. And the answer is you really can't. Regex can do massively more than any of those things can, but you have to go a little bit deeper than kind of scratching the surface to get at that. So today I'm just going to focus on the regex test function. In other words, when does a string match a pattern, and what are the different kinds of patterns that you can ask for? And then I'll probably follow up later with some other videos on fun things you can do with extract and replace. Quick mention on resources that I found helpful before I dive into it, because before last August, when I played around with Python and Excel, I had never used regular expressions, and then I used them a little bit then, and then I haven't used them since then. So I'm, just like all the generative AI experts that are out there now, I am not a regex expert. I just restarted learning this stuff recently, but it's pretty easy to pick up. So some useful resources. One is regex101.com. You just put in any regular expression here and any text here, and it will show you where the matches are, and it will explain what the pattern means. Now, this is a pretty complicated one to start with, so don't start there. But so if you just go to the home page, then you can get a blank thing where you put in your pattern and you put in your text to test. You can also go to this library here and find, interesting patterns that other people have put in. So that one that I was looking at was, this is to validate a password that has to contain one number and has to contain one uppercase letter, one lowercase letter, one non-alphanumeric character, and be between 8 and 16 characters long. All of that information is picked up in this pattern. And so if you open that up, it will pick out, like, you can use it to validate, but you can also use it to find, like, here's a bunch of text. There are 4 valid passwords in here according to those rules, and these are them. Anyway, so that's a useful one. And then the other one is, I don't know if this is the best one or not, it's just one that I found when I Googled, but regular expression syntax cheat sheet from mozilla.org explains a bunch of the stuff that I'm going to be giving you examples of. Anyway, I'm going to be showing you in a spreadsheet, obviously, because a spreadsheet is what we want. So there's various different levels of this, going from kind of very basic to much more complicated. They all have the same shape. So this is the text, this is the pattern, and this is the result of applying the function regex test to the text and the pattern. So having said that, let's dive on in. The most basic, does it contain a character? So by default, a regex pattern is always just, is it anywhere in there? And we'll talk about finding it at the start or at the end or other things like that later. But so here we're saying, does this contain an L? Yes. Does this contain an L? No. Simple. Just a warning that by default it is case sensitive. So does this contain a C? No. Now, a human being might look at that and say it does. A computer programmer obviously would look at it and say it doesn't, because computer programmers are not human beings. But to bridge the gap between the two, there is an optional third argument where you can switch on case sensitivity. So every other formula in this column does not have that switched on, but just wanted to mention that at the start. Oh, and I should say, this workbook is available to download in, I'll put a link below the video. If you don't yet have these functions, then these obviously won't work for you, but I'm going to also have a second copy of this column that just has the hard-coded results so that you can kind of read through and see, okay, so this should be a match, this should not be a match, and so on. So that's case sensitivity. Matching the start or the end, you can use these characters, this caret for the start and $1 for the end. So this says starts with ST. This says starts with ART. So start does start with ST, but does not start with ART. And likewise, the fin, if you take the dollar out, you get true, but it doesn't end with fin. It does end with ish. So that's how you mark the start or the end of a string. Now let's talk about groups. So if you have a group like this in square brackets, it means any one of these characters, as long as you put only single characters in here. If you want to have bigger blocks, that's a separate thing. We can come to that later. So here we're saying, does this start with a D or a G or an M? Again, case sensitive. It's going to be uppercase. So this one does, this one does, this one does not. And groups can also have ranges. So you can have the range D to H without having to spell out D, E, F, G, H. And you can have, the range A to Z or A to Z to say matching any uppercase letter. You can also, like in this example here, you can stick two ranges together. So you can say this, for example, would match any uppercase letter or any lowercase letter. You just have from here to here, and then right next to it from here to here. Let me just put that back where I had it. So this one is saying starts with a letter between D and H, uppercase, that matches. This one does not match because M is not between D and H. This one does not match because of case sensitivity. So it's not an uppercase letter between D and H. It is between F and P, but it's not in the right case for that. You can also have negative groups and ranges. So here, for example, now the slight confusing thing is that the caret, this power of, if you're used to thinking of it that way, but the symbol is actually called the caret, I think, has two meanings in regex. So it is both the start of string operator. I don't know if operator is even the right way to describe it, but it stands for the start of a string, and it stands for negation in a group like this. So that these square brackets mean it's group. That being the first thing in it means not this stuff. In other words, here we're saying, does it start with anything except D, G, and M? So here it doesn't because it's a D. Here it does because P is not in D, G, and M. And you can also negate ranges. So you can say this starts with anything that is not a letter between D and H. So D fails that because it does start with something in the forbidden range. M passes that because it starts with something not in the forbidden range. It's case sensitive, so this lowercase d is okay because it's not in the forbidden range. And just a kind of usage note, again, human versus computer. Human, you might look at this and say, oh, not between D and H, so it means A to C or I to Z. But it actually means any character at all that's not an uppercase letter between D and H. So here, for example, ampersand is okay. So if you use a negative letter range, it doesn't mean some other letter, but it means any other character. So that's just a little warning. Okay, so you can do repetition by putting a number in curly brackets. So it just means that whatever thing came before, you want it that number of times. So here we're saying, does this contain 5 consecutive zeros? Yes. Does this contain 5 consecutive zeros? No. Here we're saying, does this start with a group of D to H repeated 3 times? In other words, start with 3 letters between D and H. So you can start to see that the patterns are starting to get a little more complicated. It gets rather wilder as we carry on down, but you're already getting into kind of things that would be very hard to do with just sort of regular Excel formulas. So let's talk about wildcards. There are a few of these to know about. The first one is a period or a full stop, if you're on the other side of the Atlantic, as I once was, matches any character. So this is any character followed by ATCH. So it matches match, it matches patch, it matches scratch. But if you need to start with any character followed by ATCH, then it does not match scratch because this is not one character, it is 3 characters followed by ATCH. So it matches any one character, but not multiple characters. Likewise here, you can use it as a test for length by using the period or full stop. I never, when I'm speaking to a human being, I will say period if I'm speaking to an American, or full stop if I'm speaking to someone from Europe. And when I'm making videos, I never know who's watching, and I'm like, Z, no Z, no period, no full. Anyway, I'm gonna go American today, and apologies to the Irish. So you can use a period, which remember matches any character, with a number to say needs to contain this many characters. So this only has 5 characters, so it does not match, so you get the false. This has 6 characters, so it does match. Again, remember that the default is contained, so this has 7 characters, but it still matches. If you want it to be exactly 6 characters, then you can say start, 6 characters, end, and then this one would not match. This is just a fun little one. I have used this with Excel-style wildcard characters. I often download data from an HR system that includes names with many middle initials, and if I'm going to be putting things in a sort of display output, I don't want the middle initial because that's a sort of excessive formality. And so you can, in a text filter, you can use a question mark for a wildcard. So you can say contains. This is basically anything followed by a space, followed by a single character, followed by a space, followed by anything, and that'll match the names with a middle initial. And the equivalent in regex is just to use period space, period space, period space. You might wonder, by the way, why regular expressions gets shortened to regex, and as with everything, there are flame wars about this. I don't know why, but I call it regex. I think there are people who call it regex as well, but it sounds wrong to me. Anyway, so this pattern will match any 3 characters separated by spaces. So if you have a middle initial, it will pick that up. Although if you have something like this, then it won't match that, and you'll have to have a more complex pattern, and we'll talk about optional characters a little bit later on. Okay, so we've talked a bunch about special characters. So you've got this period that means anything, you've got this caret that means start of string, you've got dollar that means end of string. But what if you want to find a period or a dollar or a caret? Well, that's where, and there are lots of other special characters we'll come to later, that is where the concept of escaping comes in. So basically any special character in a pattern can be escaped by putting a slash before it. So this is saying, does it contain the text Gmail followed by any character followed by com? So it matches this, hi@gmail.com, but it also matches this, hi@gmail/com, which you probably don't want it to match. So in this case, you want to match a literal period. So it's going to be backslash period, not just period. And same if you wanted to match a literal caret or literal whatever else. And again, if you're used to wildcards in Excel, for example, if I search for a star, that will just match anything. I don't know if I even have a star here, but let me just put in a star so that I can find it. So if I search for a star, that will match. It's a wildcard, so it'll match any character. So if you want to escape that, you put in a tilde, and then it'll match the literal star. So the equivalent in regex is a backslash as your escape character. Okay, more wildcards. There are some handy wildcards for matching families of things. So for example, \d matches any digit. You can also use 0 to 9, but it's just a little handier to write \d. So just, does this contain any digits? Yes. \w matches any letter or digit in a very English-centric way, which is to say it doesn't match any accented characters, it doesn't match any non-Latin alphabet, it doesn't match any non-Arabic numerals, etc. But just it's the equivalent of A to Z, upper and lowercase, and then 0 to 9, but considerably more compact to write. And then, so this is with lowercase d and w, and basically uppercase D and W is the opposite of that. So \d matches any non-digit. So if you're trying to make sure that if you're trying to make sure that something is all numbers, so let's say this is supposed to be 5, 4, 3, 2, 1, you could say starts, then there's digit. Actually, wait, we haven't even done the right kind of repetition to do that. So you could, when you know how, you could say starts, then a digit some number of times. I won't show you how to do some number of times right now because I don't want to spoil the fun for later. And then ends, and that would match. But another way to say, does this only contain numbers, is to say, does it match any non-number? And that's the backslash uppercase D. And likewise, backslash uppercase W is very loosely defined any special characters, meaning anything that does not match the pattern W. So this password would fail some tests because it only contains letters and numbers. And then finally, this backslash lowercase s is any white space character. So like a space, a tab, a line break, any white space is matched by that. And so, here you could use it to make sure that you've only got one word in your password. Okay, so then more about repetition. So we talked about how you can have something a fixed number of times, but then there's also the option to match something any number of times. So D star means any number of Ds. So this contains D, yes, pass. D plus means any positive number of Ds. So does this contain at least one D? Yes. The subtlety of the difference between them you can see if you look at this one. Does this contain any number of Ds? Well, yes, but the number is 0. Sometimes you want that, sometimes you don't. In this case, does it contain at least one D? And the answer is no. This one is a way of saying, does it contain at least one letter and nothing else? So it's just a word. Then you can use that syntax. Whereas here, more words with a space in between does not match that pattern because there is something that is not any of this stuff. So that's plus and star. Then the next one is optional characters, or you can think of it as repetition part 3. So this repetition shows you how to repeat something an exact number of times. And I should say there are other variants on this. So, number comma means at least that many times, or you can put in a range. So like 5, 8 means between 5 and 8 times. But so there's like a fixed number or a fixed range there. Star means 0 or more times, plus means 1 or more times. But the last one that can be quite helpful, which I seem to have lost my group for, there we go, is the question mark. Question mark means 0 or 1 times. In other words, this is an optional character. So here we're trying to match the format of social security numbers. So it's generally 3 digits, then 2 digits, then 4 digits. Might be separated by dashes, might be separated by spaces, or might not be separated at all. And so here's a pattern that matches all of those. It says, give me, remember, backslash D is a digit. That 3 times is 3 consecutive digits. Then I have a group, which is either a dash or a space, but that whole group has a question mark after it, which says this group is optional. So there's either a dash or a space, or there's nothing. Then you've got 2 digits, which again you could do as backslash D curly brackets 2, but when there's just 2 of them, it's as easy to write it that way as that way. And then again, you've got the same thing. You've got a delimiter, which is either a dash or a space or nothing, and then 4 digits. And that matches all of these. It does not match this because the pattern of dashes is wrong. So this is not formatted like a social security number. But it does match this one, which you might not want it to do because here you've got 2 different delimiters. So that is probably not a properly formatted social security number. So you might want to match that or you might not. Now with what I've shown you so far, you only know how to match it. So let's talk a little bit about capture groups. And I will say capture groups and also look ahead, look back, basically all of the rest of this are things that only really come into their own when you start extracting and replacing. But there is one little edge case with capture groups, so I'm going to show you that quickly. So the idea of capture groups is you have the same pattern, but you put brackets around some pieces of it, and that becomes a capture group. So you match the exact same pattern as above, but now here you're capturing the groups of digits. So here you're capturing these 3 digits, you're capturing these 2 digits, and you're capturing these 4 digits. And then, having captured them, you can do things with them. You can do replacement, you can do sort of rearranging, or you can reference back to them. And then here it's the same thing, except now we've moved the capture group. So instead of capturing the digits, we've captured the delimiters, because maybe sometimes that's what you want to do. And then the reason that I mention this now, rather than just kind of deferring capture groups entirely until we start talking about extract and replace, is that for this case, where you're interested in a delimiter here and a delimiter here, but maybe you want them to be the same, there is a way to reference an earlier capture group. So here I've got, if I, well, I've got mostly the same pattern as before. So I've got 3 digits followed by a delimiter, followed by 2 digits, followed by something I'll come back to in a second, followed by 4 digits. Now I've put brackets around this to say this is a capture group, so I'm capturing that delimiter. And then this here, the \1, refers to what was captured by capture group 1. So the first capture group to appear, which is here. So this is saying some delimiter here and then the same delimiter over here. So that matches this pattern where it's dashes in both, or if I made it spaces in both, it would match that. Or if I made it no spaces, it would match that. But it doesn't match this, where the first delimiter is a dash and the second delimiter is a space. And then just to get extra funky on this, just because I think it's a really cool idea, you can have a pattern like this where you name a capture group. So you inside a capture group, so again, parentheses or brackets tell you the boundaries of the capture group. First thing in the capture group is a question mark, and then a name inside square bracket. These are not square brackets. These are, I don't even know what these are called. HTML brackets in my mind. So you're giving this capture group a name, and then later, instead of saying capture group 1, which might change if you modify the pattern or add other things in or use it as part of a bigger pattern or something, you refer to it by name. So here I'm saying capture a thing called delimiter, and then here I'm saying with the \k and then the name, I want to match that delimiter again. Or you might say I want that delimiter 3 times or whatever. That's referencing an earlier capture, and then look ahead, look back. I'm just going to leave this as more to come, because for the purposes of match, so look ahead and look back means I want to match this thing, but only if there's this other thing ahead of it or there's this other thing behind it. For the purposes of does this string match a pattern, there's no relevance of look ahead and look back, because you're just saying match this and this, or this and this, or this followed by this. But when it comes to regex replace and regex extract, then you're going to be interested in not just what is the whole pattern, but identifying pieces of the pattern. That's where these capture groups come in, and it's where look ahead, look back comes in. So like I said, I'm planning to make at least one other video to talk about some of the things you can do with regex extract and regex replace, hopefully pretty soon. But for now, that is, I won't say everything you need to know, but that is a decent start on what you need to know about regex test. I'm pretty excited to continue exploring this, because this is a pretty new topic for me. But that's what I got for today. Thanks for watching. See you next time.